Inequalities and triangles. Definition of inequality. For any real number, a and b, a is greater than b if and only if there is a positive number c such that a equals b plus c. So for example, if you take 4 and 2, add them together, you get your 6. So 6 is greater than 4, and also 6 is greater than 2. The exterior angle inequality theorem. We talked about how an exterior angle, such as 4 in this case, is equal to the remote interior angles. We discussed this in an early section. Now we're saying that that outside angle is greater than each of the other individual angles. So I'm going to give you guys an example. I want you to take a look at example 1. It says determine which angle has the greatest measure. I'll give you a moment. So now we're going to look at this and we're going to say, well, we know that angle 1 here equals the sum of these two remote interior angles. So angle 1 in this case is going to be your angle with the greatest measure. Now here comes the fun one. We've got example number 2. Example number 2 is giving you guys a figure, and you have this handout in front of you. And they're going to ask you guys to list all the angles that justify the condition for A and B. A is asking for all the angles whose measures are less than angle 14, and B is all the angles whose measures are greater than the measure of angle 5. So what I want you guys to do right now is pause this video, take a look at that example in front of you, and see if you guys can list all of those particular angles. So you should have paused the video. We're coming back to this. So we're looking at this particular example. You've got, if you look at angle 14, it's the exterior angle to this triangle up here. So 4 and 11 are going to add up to 14. So 4 and 11 are the first two that you should have written down. From there, angle 11 is the exterior angle to 2 and 3. So 2 and 3 is going to be definitely less than 14 if angle 11 is made up of those two angles. The other angles, angle 9 here, because 9 and 11 are vertical angles. Your last two are going to be 6 and 7, because 9 is equal to the sum of angle 6 and angle 7. So those angles are all going to be less than 14. So again, those are 4, 11, 2, 3, 6, 7, and 9. Now we're going to move on to the next one. All angles whose measures are less than, or greater, than measure of angle 5. So we're going to look at angle 5. That's up here. Okay. So 5, we're going to start with 10, because 10 is the exterior angle for this triangle up here, the one that makes 4, 5, and 11. Okay. So angle 10 is going to be bigger. So is 12. That also means that we also have an exterior angle here of 16, okay, and 15 over here, as well as 17. So we've got 10 and 12. 10 and 12. 10 is the exterior angle over here. 12 is vertical angles. Then we've got 16, 15, and 17. So we've got 16, 17, and we've also got 15. So looking at those angles, those three other angles, I want to make sure that you guys understand why those particular angles are going to be greater than that particular angle. I want you guys to think about that on your own, and as a group discussion we are going to go over why those particular angles are going to be larger than the measure of angle 5. So be ready for that. The last thing that we're going to talk about is just two theorems that can be found in your books. The first theorem, 5.9, it says if one side of the triangle is longer than the other side, then the angle opposite the longer side has the greater measure than the angle opposite the shortest side. And then vice versa with the angles. If one angle of a triangle has a greater measure than the other angle, the side opposite the greater angle is longer than the side opposite the lesser angle. So if you think of an obtuse triangle, the side that's opposite your obtuse angle is going to be the one that has the longer side.